Good morning all of you. So today we will start with a numerical of channel section. So here is the problem. The problem is find the center of gravity of a channel section 100 mm into 50 mm into 15 mm. So you can see this is the figure of channel section, and a channel section consists of three parts. One is top flange, second one is bottom flange, and third one is the wave portion. So as we know that to find out the center of gravity in any section, that will be lie on the axis of symmetry. So in case of channel section, the axis of symmetry is the x-axis. So you can see this dotted portion. So here, first of all, we have to divide the whole channel section into many parts. So here three parts are there. This is section 1, this is section 2, and this is section 3. So first of all, for each section we have to calculate the area as well as its center of gravity with respect to reference line. So here, as the axis of symmetry is x-axis, so the reference line should be this one, the vertical line. So first of all, for section 1, which is top flange, the area of the top flange will be 50 into 15 because this is a rectangular portion. So that's why the area of this portion will be B into D, that is 50 into 15. So the answer will be 750 mm square. And the CG of the top flange is x1 is equal to 50 by 2. For the second section, that is the wave portion, that means this one, the area of this section will be B into D because it is also a rectangular portion. So here the value of B will be 100 minus 30 because the total height of the channel section is given. So for this section we need the distance from here to here. So that's why 100 minus 30, which is 70 mm, into D value is 15. And the answer will be 1050 mm square. And the center of gravity of this wave section is equal to 15 by 2, which is equal to 7.5 mm. Similarly, for the bottom flange, the area will be 50 into 15, that is 750 mm square, and the center of gravity of the bottom flange is equal to 50 by 2, that is 25 mm. So as per the formula, we have the center of gravity of the channel section is equal to A1 x1 plus A2 x2 plus A3 x3 whole divided by A1 plus A2 plus A3. So here, by putting the value of A1, x1, A2, x2 and A3, x3, we have the value is 17.8 mm. So here is the answer of center of gravity of this channel section along the x-axis. Now we have to solve another problem. So here is the problem. So where we have to find out the centroid or the center of gravity of an unequal angle section which dimension is given as 100 mm into 80 mm into 20 mm. So as per the figure, you can see the leg of the angle section or L section is different. So that's why it is known as unequal angle section. The vertical leg dimension is 100 mm. The horizontal leg dimension is 60 mm. This one. And the thickness of the angle section is given as 20 mm. So you can see as per this figure, this kind of section is an unsymmetric section because it is not symmetric about y-axis and it is also not symmetric about x-axis. So that's why in this type of case we have to calculate the center of gravity in both the axes. That means in y-axis as well as in x-axis. So here we have two numbers of center of gravity or centroid. So in case of x-axis we have to calculate x bar, and in case of y-axis we have to calculate y bar. So as per this figure, first of all we need to subdivide the whole angle section into many parts. So as we can see, according to this figure, there are two parts. So this one is the section 1 and this one is the section 2. So as per the procedure, we have to calculate the area and the center of gravity of each section. So as per section 1, that is for this section, we have to calculate the area first. So as it is a rectangular section, the value will be b into d. So here 100 into 20 is equal to 2000 mm square. Then we have to calculate the center of gravity of this section along the x-axis and the center of gravity of this same section along the y-axis, because we have to calculate the CG along both the axes. So as per the x1, the value will be b by 2. So the b value will be 20 mm. So here the formula will be 20 by 2, which value is 10 mm. Similarly, as per the y axis, the center of gravity along that axis will be y1, which value is equal to d by 2. So here the d value is 100. Hence the y1 value is d by 2, that is 100 by 2, which is equal to 50 mm. Now coming to second section, that is this one. So first of all, the area of the section 2 is equal to 60 into 20, because the total length from here to here is given as 80 mm, but the section 2 is starting from this point. So we need to deduct this much section from the total length. So this much section is 20 mm. So 80 minus 20 is 60 mm. So the length of the section 2 is 60 mm and depth of the section 2 is 20 mm. Hence the area is equal to 60 into 20, which is equal to 1200 mm square. And as per the x-axis, the center of gravity of the section 2 is equal to 20 plus 60 by 2, which is equal to 50 mm, because we have to calculate the x1, y1, x2 and y2 with respect to reference axis. So that's why the value will be this much. And as per the y axis, the value of center of gravity with respect to reference line is equal to 20 by 2, which is equal to 10 mm. So now we have a1, a2, x1, x2 and y1, y2 value. So now we can calculate the x bar and y bar value here. So for the x bar, the formula will be a1 x1 plus a2 x2 divided by a1 plus a2. Hence, by putting all the value, we have 25 mm. So according to the unequal angle section, the value of center of gravity along the x-axis is equal to 25 mm. And similarly, for the y bar and y axis, the value of center of gravity is equal to a1 y1 plus a2 y2 divided by a1 plus a2. Now, according to the value, by putting all the value of a1, a2, y1 and y2, we have the answer is equal to 35 mm. Hence, the center of gravity along the x-axis is equal to 25 mm and y-axis is equal to 35 mm. So today this much. We will discuss some another numerical in the next class. Thank you.